I would like to first welcome everybody to our June HBRC meeting. My name is Chris Mayer. I'm the president of the club since January of this year. And we have challenge meetings on March, June, and September. So hopefully everybody has seen on the website what the challenges are. Normally we have show and tell, then a speaker, but we have no speaker for these because it's going to be all show and tell for this meeting. So what I would like people to do, if you have a robot to show off, please go into the chat and just let us know that you have a demo to show, and we will give you guys the camera one by one to show off your robots. Also, what would be interesting, if there's anybody joining HBRC meeting for the first time, please say hello in the chat. It's kind of nice to see how many new people that we're attracting. And I know it might be confusing because everybody's seeing camp, but I'm the one talking. If the camera seems to be locked on camp. Our host this evening.
I see you, Ralph Hips.
I see Chris.
Yeah, I was seeing Chris too. Now I'm seeing Ralph.
That's what he's talking, I think.
Well, I'm seeing Ralph, James, and Camp, not myself. Anyways,
it might be helpful
if
if
who's
people
new to the group. All right, it looks like we do have a couple of new people joining us, so thank you very much for joining us tonight. Hopefully you'll get inspired and see some really cool robots. This group is all about building robots, so hopefully we can inspire you to build your own. We do have a lot of kits and plans for first robots and more advanced robots, so just ask in the chat for now. And if you're interested in joining any existing projects, which is a little bit easier for some people to get started, please let us know in the chat and someone will reach out to you directly and see what your level is and what your interest is in some of the projects that various members here already have in progress. Is Dan Tuschler online?
No, he says he wasn't going to make it this time.
He's not going to make it. So we're going to pass up on the Treasury report for the group. Is there any other robot-related news that somebody wants to talk about, or any other club-related news that anybody wants to mention? Okay, I'll take that as a no. I guess with stay-at-home orders, there's not much in robotics happening out in the real world, which is why it's important for us to keep this going while we're here at home. We've got lots of extra time now to be building robots. So I guess without any further ado, Camp, do you think we're ready to start showing off robots?
Ready or not. So first thing I want to make sure everybody's got their badges. Everybody got your badges, right?
We don't need no stinking badges.
Also, there's no masks required for this meeting.
Yeah.
Except for Mark Thornton. Mark, I think you really should be wearing a mask. So, 18 years ago in 2003, a group of us were lamenting the lack of building activity at the club. And it occurred to us that the building activity coincided with contests. We had a line following contest and a maze busting contest, but these involved stages that had to be set up and stored, and there were winners and losers, and people did it one time and the robot was on the shelf, and that was kind of the end of it. So we wanted a contest that, or we wanted an event that involved no setup. We met at the Castro Middle School at the time, and there were tables all over. We thought, let's do tabletop soccer. And Bill Benson would say, that's non-trivial. We'd say, oh, let's put nets around it so if the robot falls, you can catch it. And but no, that's setup. That's something that you'd have to store and set up and all that. And that's when the TableBot was born. A TableBot is a robot that survives, lives, and plays on the table or pays the price. And how do you get to tabletop soccer? You get to tabletop soccer the same way you eat an elephant, one bite at a time. Ching. So we did it in phases, and traditionally it was June, August, and September, although now we're doing it in March, June, and September. But the idea, this is the phases. Phase 1 is to go from one end of the table to the other and back. Phase 2 is to find a block and push it off the edge of the table. And phase 3 is to push the block into a shoebox mounted at the end of the table. Now, I'd like to start this thing off, if I may, with Buggy, my TableBot, and I'm going to attempt to do, with the assistance of my lovely fiance, Nancy Thorson, I shall attempt to do phase 3 with Buggy. Can you go on there? So I posted a video earlier, and I really need to redo this thing with camera because I'm pretty much convinced that ultrasonics just doesn't have enough to be able to do this thing.
That's a really nice cube there, Camp.
You like that?
I do.
Unbounded Robotics. I like the color. This is the official cube of the TableBot Challenge. Let's try this again. This is not a contest, by the way. There are no rules. Come on. I'm going to count that as 1.
I have my official cube here.
Yeah.
I had to pull mine out of storage.
Yeah, so the concept is I've got an upper and a lower ultrasonics, and the lower ultrasonics is for sensing the block, and the upper ultrasonics is for sensing the box. There you go. I'm gonna quit at that point. So that's Buggy doing phase 3, more or less, TableBot Challenge. Thank you very much. What's next on the TableBot Challenge, or on the HBRC Challenge?
I think the next up is going to be Luke Keys. So welcome, Luke. Thank you for joining us. Looks like this is your first time here, so that's great.
Yeah.
Luke actually did a presentation at an HRBC. He's out of Austin, Texas. Thank you, Luke.
Yeah, I don't have a TableBot, but my bots can't fit on a table. So let me show them off. Hopefully you can hear me. I'm on a speaker phone. All right. Where does this go? Okay. All right. So that is Artie. That's by his middle height. He can go all the way down to, you can go down a little bit more. Here, let me show. So he's based on a Balder power chair. Balder power chair can raise and lower. So he can go kind of all the way down, and that's really great when transporting him. And then he can go up to about close to 6 feet. He's based on a Balder power chair. I've got Sabertooth 2x32, Arduino Mega. That runs the motor systems. His head, has 2 NeoPixels and an Arduino Uno in there. I'm eventually going to put in a Raspberry Pi, probably Raspberry Pi 0W. And his body, this is all custom laser cut. And if anyone's interested in the laser cut designs, I can share them. But this is his panel here. It's called his party panel. It's a little hard to do, but all right, there we go. So that's a flux capacitor, little car charger thing that my wife got me. Got some buttons. There's a space right here. It's hard to see here. I'm gonna move my. Maybe I won't. Hold on, I'm gonna move him closer. Okay. Okay, there we go. Okay, so he's got a space for a little LCD panel that I'm going to put in. It's got some status indicator lights, a speaker. Let me swing him around real quick. So here we go. We're trying to look at. So this is his power distribution box. Got a voltmeter on it. His motor control box. And see if we can look inside. Nice little door design. It makes it easy access to get in and out. Here we go. He's got a speaker, and I can't swing it around, but he's got plenty of room inside for more electronics. I have here, this is an Atomic Pi. That will be going in, as well as I have a Jetson Nano as well. So that is Artie, and sorry, I hope not inducing motion sickness. I'm gonna put this up for a second and show Annabelle. Okay, so this is Annabelle. Annabelle is pretty much Artie's sister. Basically, anything I do on Annabelle, I do on Artie. Anything I do on Artie, I do on Annabelle. She's got this is an Android tablet. It's running a custom program with animations. She can do different facial features. She's not connected to her onboard Raspberry Pi right now, which is why it's angry. But when she connects, it goes happy. Text-to-speech. So we have a custom GUI that allows us to type whatever she wants to say. We also have scripts so we can easily like point and click through common phrases that she's going to say. Also, this is a quantum wheelchair. Down there, you see. I'm going to turn her around. This is her mobile command center that has the laptop that runs the GUI and everything inside. And this is her motor control box. This has a Sabertooth 2X60 and an Arduino Uno with a USB shield. And you might wonder what's the purpose of these. I'm gonna put this back up. I'm part of a group called Bot Party that, let me get on camera. I'm part of a group called Bot Party that focuses on human-robot interaction. So we mainly around improv theater. So we have these two big robots. We take them on stage. We work with improv actors and actually go through different games. We had a video of one of our performances on YouTube for a while, but it recently got taken down due to music copyright. So we're going to try to figure out how we can work around that. See if we can do a sound-alike video, music or whatnot. But once we get that up, I'll definitely post the link in the mailing list so you can see. But yeah, we basically just are trying to do improv theater with robots. And, you know, obviously we've been limited by the current events, but we also take our robots out to things like Maker Faire and just have them interact with the public. We take the schools to promote STEM. One of the things I do last robot I'll show. Okay. So this is how I started my journey with robotics. This is Lego Mindstorms. So, you know, when I come in and I got these big, giant humanoid robots, I always try to show the kids that, look, I started with Lego Mindstorms. There's other Lego kits. I actually just gave a Lego knockoff kit, robot kit to a kid, and it was like $40. So getting involved with robots doesn't necessarily need to be expensive. It doesn't necessarily need to be, oh, you got to take, you know, years and years of electronics engineering. Just get started, and then once you hit an obstacle where you need to learn electronics, use something like Arduino, and you know, learn as much as you need to get by. Same thing with programming. You know, you can get a Raspberry Pi and start learning as much Python as you need, cobble things together. So it really helps promote STEM, because you know, you show, hey, this is what you can do. This is where I started, and yeah. So those are my robots. Thank you.
Thank you very much, Luke. That was awesome. Hey, and that's perfect. In this show and tell, and folks, I want everybody to, you know, limit it to 5 or 10 minutes, but let's be heavy on the show and light on the tell. You can pick up the details and hows and the wherefores in the forum or even after the meeting. So Chris, who's next on the docket?
Okay, sorry
Hello,
about
Chris
that.
Mayer.
Yeah, the mute and unmute is difficult when you're not a co-host, but it looks like our next presenter is going to be Fergs.
Cool. Okay, I will slide down the video here. Yeah, so about 2 months ago, so this is kind of on the edge of homebrew robot, but about 2 months ago, James posted to the mailing list that he had found one of the UBR1s on Craigslist. And obviously this is a robot that I was part of the design team. And so I managed to buy one of these, and I've managed to get it up and running on not only on ROS, like a more recent version of ROS, but more recently I've actually worked it out and got it working on ROS 2. So I'm going to bring the robot up a little bit here. And so right now, unfortunately, it's not a great demo of like, oh, let's go navigate and whatnot. We'll do that at the next one of these camp. I'm definitely going to have it working by then. And that'll be robot navigating in ROS 2. So all of the drivers you're seeing right now are all in ROS 2. So I've ported over the head controllers. I've even got the Cartesian controllers for the arm up and running. So all of this is teleopt right now. But basically, a lot of code that I wrote in like 2013, now updated to work with the very latest ROS 2 on ROS Foxy. So that's also running on Ubuntu 20.04. And so I've been blogging a bunch about this, and you can find sort of all of my trials and tribulations with ROS 2 on my blog, robotandchisel.com. And I posted a link to that on the mailing list earlier there when I was talking about that. So yeah, so everybody who's playing with one of their little cubes, this guy will be picking up his favorite little cube shortly. Going to be getting navigation and move it back up and working on this, but all under ROS 2, which is kind of cool.
Say, Mike, you say you got it on eBay?
Craigslist.
Craigslist, how much it cost?
What was that?
How much?
So they were selling them. I ended up going back and forth a bit. Obviously, shipping was a big portion of it, getting it out here to New Hampshire. But they were sort of selling it for around $5,000.
Excellent.
So yeah, it was unfortunately it was missing the laser. You can find a whole lot of it about. I actually have a blog post on restoring a UBR1 which involved like finding replacement batteries and finding, I had some extra lasers luckily because it was actually missing the laser, and sort of figuring out how to get the computer working again and then upgrading that and whatnot. I've spent a bit of time working on it to get it back to a working state, but it's there, so that's kind of cool.
Chris, who's next
All
on the
right.
list?
Thank you very much. Next up on the list, we have Steve Dillow. Welcome, Steve. Thank you very much.
Go Steve.
Hi, I need like 5 minutes to boot up my robot.
Let's
All
go
right,
to the
we'll put you back in the
Steve.
queue. We'll
Yeah,
check back
get
in
me
the
next, and I shut it down because I didn't want to run the battery too much.
Okay, we'll move
So-
on then. It looks like we have Diane is up then with the robot, and then Steve, you'll go after Diane.
So Diane is really Ralph. That's my wife's computer, so I didn't change the name. At any rate, I have this, which is a commercial kit called UC Tronics. They have a couple different versions. This is the Raspberry Pi version. I made several modifications.
Ralph, did you say that robot had a name?
It's made by a company called UC Tronics. I can post it to the mailing list. But I've modified it somewhat. The speaker on top here is being driven by I2S amplifier, and I had to reverse engineer the hat board, which drives the motors and LEDs, and it's got ping sensor, and you know, I added the 16 channel I2C servo driver, and uses 2 of the LiPo batteries, so it's got a decent power supply, and it's all running Python and is connected to Remo.tv. So if somebody can pass the presenter ball to me, then I can share my screen and show you what it looks like.
Yeah, everybody's able to share screens, Ralph.
Oh,
You're able to share your screen. Go ahead.
okay. Let me try this here. And we want to go to where is it?
So you're using your wife's
Oh, here it
username.
is. Yeah, for the moment. Share. Okay, so as I move the robot around, you can see the camera. And let's see, how do I scroll down here? Well, like the buttons are visible anyway, so I can drive forward, drive backwards, turn left and right, and then there's separate camera controls, so you can tilt the camera up and down, and pan left and right.
That's Frisky Bot, is it?
Yeah, that's my login. They have channels. So there's San Jose, which is the what you're seeing now. But remember the creepy head from Maker Faire? Well, that's the other channel here, but it's not online at the moment. You can see it says
Who could
live.
forget the creepy head?
And so I just wanted to, oh, there we go. Now I can scroll. Oh, and then you can center the camera. So I just wanted to quick demonstrate my project here. My let's see, I guess he's 7-year-old nephew now in Raleigh, North Carolina. He gets a blast out of driving this thing around the house from Raleigh.
So this is basically a, this is basically a Remo robot, right?
Yeah.
Remo TV.
Yeah. So if you look for Frisky Bot 1 and then San Jose channel, then at the moment I don't have it open to the public, but I can make it public if people want to drive it around for a little bit. Let's see.
Really quick question, if you don't mind. Could you speak a little bit as to the difficulty and the level of expertise you need to get your robot up and running on Remo TV?
It's actually pretty easy. I mean, because I did things a little differently.
Easy for you.
Basically, you download the Python program, or you create your account, you download the program, you edit the Python script to drive your motors, and they have several pre-selected ones or whatever that can, for sort of standard hardware. Mine wasn't included, so I had to write some code to drive the motors. But
And what about camera access? How does the Remo TV software get access to anybody's camera?
So it uses FFmpeg to encode whatever camera you've got and sends it as a stream to the web browser on the server. And then that basically forwards it to your web browser.
Oh, so it's using the third-party FFmpeg app to do that work.
Yeah.
All right.
So
thanks.
that just gets launched as an independent process. So it's the Python script kind of runs in a loop, doing monitoring the buttons, and the video feed is kind of independent as a separate process.
All right.
Very
Thank
nice.
you very much. Also, at this point, I'd like to tell everybody, if you have questions for the people we're showing off the robot, and Camp, for you too, it's easier if you just type them in the chat window, because when you speak, you are interrupting the video stream of the presenter. So people, please ask questions in the chat. And
I'll
if
stop
you're done,
sharing.
you can stop sharing and we'll go on to the next. So the next person on the list is Bob Allen. So welcome, Bob Allen. Let's see what he has to show.
I'm ready.
I'm sorry about that. That's right. You were in the queue. We'll go to Steve Dillo next.
Okay. All right. Let's see here. Battery's very low. Okay. Let me just flip my camera around here. Tap on me. Flip the camera around. Okay. So this is my current status of my SOPI rover that Marco and I have been building one of these. I kind of was inspired by him to build this. So it's come quite a long ways. I have sweep LiDAR on the front now. So have an active LiDAR. This is running the Ubiquity Robotics version of ROS. So this is kinetic. And some of the more recent additions is MicroStrain, which makes industrial sensors. They lent me one of their fancy IMUs. So I have a really awesome industrial grade IMU with GNSS on my rover now. I have split power between motors and sensors. So for people who haven't been following the project, this is a Raspberry Pi 3 talking to an Arduino Mega for the motors. Let me get my joystick here and actually, hold on. Let me get. There we go. So there we go. So hopefully my phone doesn't die while I'm doing this. So let me give a demo here. We're just gonna, because of time, we're just gonna roll back and forward here a little bit. So let me just like that. Ah, stop, robot. Yeah, still a few bugs to work out. Can people still see this?
Yep, we can still see it. Looks pretty cool.
I've been hacking on the teleop control recently. So there's like a bug where it doesn't always stop as soon as I let go of the dead man. So that's a little disconcerting. Like that. Okay, so I'm gonna stop there. Yeah, I'm gonna stop there. Late breaking code. So that's, yeah, this is mostly 3D printed. Been working on it for about a year and I've had the teleop going I had like a hardwired controller last fall, but have since switched to a PS3 knockoff joystick. And there's like, oh yeah, this is the other cool thing I added recently is there is now, I don't know if you can see that under there now, there's a network switch under there now for debugging. So I can just plug an Ethernet cable right in there. And again, LiDAR, using Dynamixels for the steering. So Dynamixels for the corner steering. And this is using what I call Hackerman steering, where it's not, I'm not actually, I have the measurements and the computation and everything, the figures and everything I need to do proper Ackerman. But for demo purposes, I just have the front wheels do the turn and then the back wheels just reflect whatever the front wheels do. Because I actually sat down and did the calculations during quarantine and realized that, hey, you know what? With some exceptions, you know, rare exceptions, most of the time when you're doing the actual, like, how do the back wheels turn for the corner steering, it turns out they're pretty darn close to 180 degrees anyways. So, especially while I'm kind of getting everything just shaken out on this, you know, all the prototyping done, it's just easier to take the angles for the corner steering on the front and then just like multiply by -1 for the back. And that's pretty much about it. Next thing to do is to hook up the motor encoders. So that, yeah, next thing to do is hook up the motor encoders so I can pair odometry with the IMU And then, you know, we've got some autonomy going here. That's kind of about it. I'm gonna try and drive it back without crashing. So, oh yes, it wouldn't be a demo. I have to like thank my sponsors here at Circuit Launch in Oakland, who have been hosting me as one of their roboticists in residence over the past, say, 6 or 8 months. So I have myself an awesome little desk here with a space to leave the robot. That's where the robot normally sits. And they have a real thing for robots. We have several other roboticists in residence here, and they have their own robots that they're working on. And you may recognize some of these. So they've been really cool in hosting me and giving me a space to sit my robot and to build and have access to their 3D printers and everything. And they're a hardware co-working space focused on hardware startups in Oakland, out near the airport. So they've been really awesome. And that's pretty much about it. Any other questions?
There was a question in the chat about the LiDAR.
Okay. It is a, this is a scans LiDAR. It's called a sweep. This was a startup company. They were trying to do sort of like a ruggedized outdoor LiDAR for drones a few years ago. I was partnering with them because I had a robot startup myself at the time. So that company, Sweep, is not around anymore, but I did have one of theirs because they when I was running Service Robot Labs, they're like, oh, hey, have a LiDAR, because maybe if this works for you, you'll buy a bunch from us and we'll actually, you know, have sales and stuff. So that's just kind of like, I mean, the nickname for this robot is, so the robot name is Tenacity, like in like spirit, opportunity, you know, I guess perseverance is going to be the next one. So this is Tenacity. The nickname is Spare Parts Rover, because a lot of the parts here are spare parts that I had either I've accumulated over the years or that came from my former company, Service Robot Labs. So one more thing I will say here, just have to give a plug here. Curiosity drives us forward. Curiosity drives us forward. Tenacity sees us through. So yeah, the LiDAR is from a company called Scans, which is not around anymore, and it's a neat little LiDAR.
All right, well, thank you very much. Looks like there's no more questions. If you have questions later, please add them in the chat for any of the presenters. And it looks like up next is going to be Bob Allen.
We can't hear you, Bob. You're muted. Still muted.
Yeah, Camp, you have the ability to unmute Bob Allen if he doesn't.
You can just press the space bar. That will unmute you temporarily if you hold the space bar down.
Okay, while Bob Allen is working out his technical difficulty. Oh, there he goes. Okay, take it away, Bob.
Oh, still can't hear you. You're unmuted, but I think you're
Bob is unmuted.
to the wrong audio input.
And Camp, you did not yet figure out how to set the spotlight?
Bob is now.
Still can't hear you, Bob.
He is unmuted.
Unmuted, but I bet the computer is set to the wrong audio input source. In the Zoom window, down where you have all the people, down at the lower left, there next to the mute button, there's a little arrow. If you click on that, it shows all the audio input possibilities. Just make sure the right one is selected there.
Just point.
Still can't hear you, Bob. Want to try joining from your phone, maybe?
No, it's not going to work.
Well, I think what we can do is, Bob, I'll let you decide if you can chat through your demo and just type in the chat window because we don't have a microphone on you. I'll leave that up to your decision, or if you want to try to work that out, we can go on to the next demo and hopefully come back to you. So if you could use hand signals to let us know. I'm assuming you're saying go to the next and you'll work on your technical difficulties. All right, well, thank you. Up next, we have Nancy. And then hopefully Bob can either dial in or figure out what the microphone situation is.
All right.
Take it away, Nancy.
This is my fiance, Nancy.
Hi.
And I don't see you. I still see Bob. So you're going to have to unspotlight Bob and spotlight yourself.
Hang on a sec. Spotlighting. My fiance, Nance.
Hi. Well, I'm building my first robot from my Little Blue Robot book. And we now have, he walks and he swings his arms. And by September, he will talk and he will have eyes. So I'm going to turn him on and he's going to walk across the floor. You'll notice that Camp's wiring.
Wiry's 15 years old. Used to be a basic stamp. He's now an Arduino.
Yeah, but he's kind of messy. So women like things a little neater. So I'm doing mine all from the back. So I'm going to turn him on and he's going to walk across the floor.
Which wiring on too?
My way.
Wiry's got ultrasonics, so when he senses an obstacle, he turns around. We'll put ping sensor on Robbie also. So that's, let's hold him up. Pick him up. So that's Wiry and Robbie from Camp and Nancy. Thank you very much.
Thank you.
All right, thank you, Nancy. I have a feeling you're going to be building a lot of robots now that you're with Camp.
Yeah.
Okay, so up next we have Alfred Barberina. So Alfred Barberina, take it away.
Sorry, can you hear me? Wait 1 second. Can you hear
Yep,
me?
we hear you and we see you. Thank you.
Okay, perfect. So I'm going to do the robot arm challenge 1 and 2. You know, the one basic one, just get it to move. And then phase 2, get it to pick up an item in a known location. So I need to switch my camera though. 1 second. All right. Can you hear me?
Yep, we hear you.
Perfect. Okay, good. So if you can see, so I made this, it's made from scratch. It's 3 NEMA 23 stepper motors, an Arduino, 3 stepper motor drivers. The gears are made on my CNC machine. Just use some square aluminum 3/4 of an inch pieces. And then a little gripper that I found on Thingiverse. Some little fans to keep the stepper motor drivers cool. And so let me do number 1. So let me get this. So this is phase 1, getting it to move. And it zeroes itself out, kind of homes itself, so horizontally and vertically. And then the next step is I'm going to do the sequence. So it's going to pick up this block at a known location and drop it in the basket over there. Just pause in between. Ta-da! It's always nervous to know if it's going to work. I'm also working on, so that was phase 2. And I'm working on phase 3, which is to find objects. I don't know if you can see my screen. Let me move it up a little closer. So here you saw in the cubes, you know, I put on the little Aruko symbols. So I'm using OpenCV, you know, running this on the PC side of things. And it right now can detect, you know, the different cubes. And then I'm going to get it to then from there know how close it is to the different, you know, to the camera center itself, and then pick up, you know, a object in a, you know, non-known location. So, so that's it. That's the demo.
That's really cool. And I'm sorry I missed it. What was the main processor that you're using to do the vision?
Oh, the vision. I'm just using my PC, actually. I'm using OpenCV, which has the Aruko libraries built into it. So for this phase 2, I didn't, you know, it's not using any vision. It's just going to a known spot right now, this marker right here, you know.
Oh, okay. So in the future, you're going to do the video processing on the PC, and it will send information to the robot over like a serial link or?
Yes, exactly. Over serial to the Arduino, and then there, you know, I give it the basic commands, move down so many degrees, forward so many degrees, and things like that. I have all, you know, all the PC does all the brains with the inverse kinematics and things like that. But it's not there yet. So just phase 1 and phase 2. So.
All right. Well, if we were there in person, we would give you an official phase 2 certificate for the ARM challenge. So we'll keep in mind that you've done it. So when we do get real meetings back again, we'll get you in the certificate book. Let's see. Really quickly, so if you can unshare your screen, I want to share my screen really quickly just to show people what the other challenges are. So on our main web page, we have, I think, 5 official challenges. We used to have a really nice booklet where you would get a certificate suitable for framing on your wall showing that you've done these challenges. So even though we're not giving out certificates at the moment, we will be giving them out at our next meeting that we can do after COVID. So for those of you who have been collecting these, keep at it. Okay, and next up we have, actually, I'm going to introduce to you Jim D'Annunzio. I hope I pronounced that properly. He's from the RSSC,
Yes.
and he's going to talk a little bit about the Robotics Society of Southern California. It looks like they have a really interesting group, very similar to ours. They show off robots, and they have show and tell, and they have host speakers. So he's going to show us a little bit about what his group is doing. And hopefully we can get some coordination going between the groups. I think that would be great. So take it away, Jim.
All right, thank you. You can hear me?
Yep, we hear you loud and clear and see you. Thank you for joining us.
Yeah, it's a pleasure. I'm glad I finally made it to one of the meetings. I didn't make the last one, but I did watch it, and I've visited Maker Faire Bay Area a couple times, and I came by your booth and chatted, and that was the extent. But and I'm on your mailing list as well. But yeah, I'll show you a bit. Okay, you should be able to see my screen now. So I'm currently the vice president of this Robotics Society of Southern California, and we're based in Long Beach, California. And when we were meeting in person, we were at the Cal State Long Beach, the meeting once a month. And during COVID-19, we've been meeting virtually with Zoom as you are a few times a month. The club started in the late 70s. It goes way back. I've only been a member since 2015 or so, but the club goes way back, and it has started when hobby robotics was really painstaking to do, and they've come a long way. But so we have the current president is Ben Partida, and we have a couple hundred people on our mailing list or so. It's a Google group, and our website is rssc.org. And so we have contests, as well as every few months we'll have a contest. And we have not had challenges. I kind of like that idea. Challenges can be done at your home without having to meet, and kind of like that idea. So we're going to try to work that in. I hope I'll try to suggest that. But I have a video here to show you some of our past contests, as well as show and tell. we also have lectures, as you do. We have an ongoing lecture in artificial intelligence and artificial intelligence and robotics. Dr. Bruce is a retired neurologist who's been giving these talks, and it varied from SLAM to AI, like A-star, pathfinding, and lots of things, and neural networks. So let me bring up this video and show you, instead of just jabbing here. Let's see.
Orange handle orange. Orange. I go, well, I don't want to.
Oh my God. So it's added on to the map, exploring as it goes. This is called natural color. You are locked in.
Oh, thank you. I see Mark with his bumper sticker there. So thank you for representing.
Got that from you at Maker Faire.
Oh, okay. Great. Yeah, I think I remember. So just to show you, I have a robot. It's not turned on or anything, but I've been working on along with a few other people in our group. We've been working on we have like a special interest group for AI, and which was kind of originally founded by Dr. Bruce and some other people. And let's see. And so in that effort, a bunch of us have purchased this Slam Tech robot, sort of a test bed. And let me see if I can switch the video to the other one. So this Slam Tech, can you see that? The Slam Tech company is a Chinese company. I believe they might be in Shanghai, or I think it's Shanghai or Hong Kong maybe. And so you could buy this for about $500, and it came with this small robot. And I've taken it apart and put the LiDAR in this larger frame called the HCR, this orange robot, which is you can buy at dfrobot.com. And it comes just with the chassis. And so you have to it comes with the chassis, and it comes with the wheel, the motor, the motors for the wheels and the encoders. You have to buy all the electronics. And so I've been working on this, and this Slam Tech this original Slam Tech test bed robot was a little guy. You can see that's how it was, the size of this black diameter there. And it had wheels and encoder. It had its own motors, which I've taken off. And you can reconfigure it in the firmware so that it thinks it's a larger robot, and that's what we've done. That's what I've done here. And the same with the other guys in the group. So there's like 5 of us or 6 who have all made different versions of a larger SlamTech robot. And I'm the only one with this orange HCR. This HCR is about, it was $570 or so for the, it's a little bit expensive, but it's pretty nice, really nice painted or aluminum, and comes with bumper sensors, and it just fits together pretty well, easily. And it actually, this isn't the whole thing. It's got a 4th level and a tower for mounting like a Xbox Kinect, which I may end up doing. I do have one of those. And then, you know, I've mounted my sonar screens, sonar devices as well. And the SlamTech, it has a full SLAM implementation. It's a proprietary, but you can, the proprietary part is on a board, the main board, as a like a little card, a PCMCIA card, but the main board is a breakout board which has firmware that's open source, so you can edit that. And I had to change that code to get the wheel encoders and send all the correct information into for my configuration. But the SLAM part of the system is proprietary. You just feed it all the sensor data, and it will create a map for you, and it's all in Windows. So I have a Windows machine here, the Latte Panda, and that all the software, the high level command level software is a Windows API. And anyway, so I don't want to take I have some videos of it going, but you know, I don't have to show those this time. But I wanted to introduce myself, and I think we have a few people joining from the club tonight here. So
yeah, well, thank you very much for that intro. Wayne wrote in the chat that, and I like this idea, if you could announce your meetings on our news group, I'm sure a lot of our members would like to tune in on your Zoom meetings.
Yeah, I'm sorry I haven't done that. I'm always announcing your meeting on our list, but I didn't do the reverse. So I'll do that.
Yeah, that would be awesome.
Yeah, I definitely do that. I mean, it'd be nice to have some cross, you know, interesting mix, or communicate between the clubs, and I'm sure we'll get participation both ways. Although everybody, you know, obviously has a limited amount of time, but you could just do your demo twice a month, I guess, instead of once.
Yeah, I noticed there's a lot of similarities, even down to the $10 membership fee. Although yours is $10 a month or $10 a year?
No, that's a year. Yeah, that's a year.
Oh yeah, same as ours, $10 a year. And you said you've been around since the 70s. Camp, how long has HBRC been around? I think it was the 80s, right?
1982.
Yeah, it sounds like about the same time. I mean, pretty close.
All right, well, thank you very much. Bob writes in the chat that he's got his microphone situation worked out. So thank you, Jim. So unshare your screen, and let's hand it over to Bob Allen. Thank you.
Okay, so can you hear me, first of all?
We can hear you, but Jim, you need to unshare, stop sharing, and then Bob, you need to start sharing.
Okay. Well,
yeah, I'm not sharing anymore. I'm just have a video.
I think it's just focus.
Yeah, Camp, if you could please set the spotlight focus back to Bob.
Bob, are you in there? You're in there as Bob Allen, right?
Oh, I found it. There was a cancel button on my screen. I didn't see that way up in the left corner. I just hit it.
All right, Bob, are you ready?
I am ready if you guys can see me.
And we can hear you, more importantly now. Thank you.
Yeah, sorry about that. I have no idea what went wrong. I left the meeting, came back to the meeting, everything worked. So let's see, you guys see me? Because I see Chris.
Yeah, we see.
Yeah, we're seeing you.
Oh, okay, great. So what I've got here is a ultrasonic array. This one has 14, 15 ultrasonics on it. And it's something that I've been working on for quite some time. And I've designed a new board for it. This is with the TNC 4.1. And so what happens is there's one sonar driver, and then I multiplex the sonar driver in and out. And this board is also just a small computer board or a robot board, because it has a motor driver on the bottom of it as well. And so we can do encoder inputs, a whole bunch of I/O. The TNC 4.1, if you haven't looked at it, it's a pretty powerful little device, and it runs at 600 megahertz. And it's really, really cool. So what I'd like to do is share my screen and show the GUI that I've got that helps. When you have that many sonars, you don't know who's doing what, what's doing what. So let me see if I can share my screen. Ooh. Screen one. I guess it's that one. Share. Hang on, I'll get there eventually here. Okay. All right, so can you see that?
Yep.
Okay, so this is the GUI. And if you just give me a second, and I'll hook up the sonars and show you kind of what I do to make sense of all this. All right, so this is a GUI kind of developer program called Maguna Link that I use. And so I'll just go ahead and connect into my sonars and then start it. Okay, so you can kind of see I've got all the readings and all the distances. And this is in inches. And what we like to do is to be able to do different patterns. In other words, if you're going to do wall following, you might want to use the first three. If you want to look somewhere is really far, this sonar here looks really far away, ahead of you. And so I can go ahead and change whatever pattern I want. So I got a little LED here. So I don't know if you can quite see that LED. Let me slow it down a little bit. There's that little green LED shows what sonar is going to go ahead and fire in what order. So in memory, I was able to now load another pattern, and this pattern will start with number 15 and go all the way over to sonar number 1. So let me see if I can get that started. So you can kind of see now it's going the other direction. So here in the center, I can go ahead and set up whatever pattern I want. And select the sonar number that I want to be first, set the sonar time after it takes a measurement for it to delay, and whether or not the sonar is on or off. So like if I start clicking buttons here, we should see some zeros. Okay, so we got some zeros going on here. So that's basically being able to turn the sonars off so I can go ahead and test them. Up here at the top is just basically just all for debug. It's this Maguna Link GUI builder is kind of nice. I've just started, it's been about 2 months I've been using it. I really kind of enjoy it. So I've got, now everybody's, I mean, Camp was just talking about sonar and his 2 sonars not being very good at finding objects. And yeah, it gets kind of difficult, but last year I brought in a robot, and I'll stop showing my screen. I don't know if you can see this gray robot back here, but it's got a set of 14, 15 ultrasonics on it. And I brought that in, and it's running kind of the same software. And I brought that into the club meeting, and I just let it run around the meeting room. And we were over at one of the Google buildings, and chair legs, chairs, people, it was able to go through the whole building, our meeting room, and not run into anybody and not get stuck. So it's kind of takes a little bit of work. It's not very good, obviously, for mapping, but it's really quite good for object avoidance and getting around. So anyway, yeah, that's it. The other, I don't know if you can see kind of the orange thing back here. That's another robot that I'm working on. That's the head. It's supposed to be about 6 foot tall. And the idea is we're going to have these robots in malls in Spain. And then COVID came, and the project obviously got put on hold probably indefinitely. But it's kind of cool as well. And maybe next time I can show that. So anyway, that's it. I appreciate it. And sorry about the audio thing.
That's okay. I have a question because you said it wasn't very good for navigating. It was only really good for obstacle avoidance. What have you tried for navigation? Because I was thinking of doing something very similar using sonar for SLAM. So what experiments have you done and what have you learned? Well, some time ago, a number of years ago, we had this kind of same sonar on a large floor cleaner. And it would go around the buildings. And we started mapping it, but we didn't get 100% really working. So we haven't really had a chance to actually go back. And the project, I didn't work on it for several years. And now that I'm back on it, and we've got more powerful computer on it, the Tinsy 4.1, we're probably going to look at that and see. But for obstacle avoidance, it works really, really well. And we have different sonars. The round ones that are on the front and the side go really long, and they're fairly narrow. And the square ones are a little wider. So each sonar has kind of a different view. But yeah, I'll have to take a look at that over time and see if we can't do some mapping. Any other questions?
Chris,
Great.
there's a lot of questions that we've been asking, but no one's repeating them, so I'm going to just pipe in. Can you repeat GUI builder name again?
Maguna Link.
Maguna.
Yeah, MEGUNOLINK. It's not free. They do have 3 different versions. They got kind of like a beginner version for not so much money and a medium one, and I got the pro one that I can make an exe file and so I can distribute the file.
Thank you.
Yep. Anything else?
Yeah, there was another question about the range on the sonars, but I think you already said that there's different sonars with different ranges as well as angles.
Right, yeah. So right now I've got the distance set for each sonar to only go out about 100 inches. And I find that that's okay for doing the obstacle avoidance. It seems to work quite well. Otherwise you get too far out and you do get lots of reflections and stuff. But it's the narrow one that really works a little bit better, and finding those little legs and table legs and chair legs. Okay, anything else?
How long does it take to cycle through all of the sonars?
It depends on the distance. Because what I end up doing is I send out the init, I wait for the echo. When the echo comes back, then I've got a reading. If the echo doesn't come back within a measurement of 100 inches, then I just say it's too far and I go to the next. So on my GUI, I had where I can put in a time. So I can go ahead and put in a time delay after it gets the echo. So all the other echoes can go away. So it can be as fast as 10 milliseconds for each one, or 1 millisecond. And it gets, if you get too quick, it gets a little inaccuracy. But it's mainly geared by how long it takes to get the echo back.
Right, because if it was going to be several seconds, then that could be a problem for obstacle avoidance, because by the time in several seconds the robot could move. But it sounds like we're talking milliseconds.
Oh yeah. Well, you're talking fairly quick. I mean, when I had it at the club meeting, I mean, it was going around and not running into people, and I just let it roam around, and it did real well. So it's within probably 100 milliseconds for the whole loop to go around.
Very, very nice.
Are those single transducer ultrasonics or double? And if single, comment on the minimum range due to the ping.
I'm not sure I understand what you mean by double. These are they send out the ping and then they wait for the echo. So it's a single, each transducer is a transmit and receive. And this particular way I've got it set up is about 16 inches, but you can go ahead and do some software to get down to about 4 to 6 inches.
Yeah, I'm super familiar with that. I just wanted you to mention it for the team.
Okay, appreciate it. Yeah, there's an inhibit to look at because what it does in the driver, it waits a certain amount of time and then it gets a ping. So if you decrease that time, then you can get a little bit better distance. Great. Anything else? Well, I appreciate the time.
All right, thank you very much. That was all we had on the list. I'm actually going to show a video of my Safeway robot next. So I'm going to share my screen and let me know if everybody can. Is everybody seeing that?
Yep.
Okay, I'm going to talk over the video and I'm going to play it back at 2x speed so we can get through it in a couple minutes. But this is a robot that I'm building with John Erickson and John Carlini. Our goal is to have this robot go to Safeway, get our groceries, and bring it back. Now, I know there are companies that have delivery robots that will go get your pizzas, or we'll deliver from Safeway to your home, but that requires a human to have to do the grocery shopping, load up the robot's box, and send it on its way to your address. We want to do all of those steps completely autonomously. So the first step that we're seeing here is the robot successfully making it to Safeway. We had to follow it along because it was its first voyage. We had to do the shopping and load up the box. But it did manage to make it to Safeway and halfway back. The only reason it came halfway back is because you'll notice the driving is rather erratic, so we figured it went probably about 1.5x the distance that it should have, and the batteries died out. So we figured with a good driving and full charge, it can easily make it to Safeway and back to my apartment. So here we are back up the hill with the box of groceries. After we can get it to Safeway and back autonomously, the next phase is we have a robotic arm that we're making that can grab things off the shelves inside Safeway, so that we would pre-arrange to have pre-purchased things, or maybe just have a credit card on the robot that we hand to the cashier. And the idea is that you can semi-autonomously drive this from your living room to Safeway, use the robotic arm to get your loaves of bread and cans of green beans or whatever you want, pay for it, and bring it back without any human intervention. The next thing that we have that you don't see in this video is it now has vision. So we now have a Raspberry Pi camera, and it can now follow objects of any type. So rather than just following fiducials or Ruco images or orange cones, I can basically take any image I want, clip out a polygon of what it needs to follow, and it will go towards that object. I was inspired by a lecture at HBRC. Someone was talking about how bees navigate. And basically how they navigate is they have a waypoint, and it's like they have a 360-degree image of what the world looks like from that waypoint. And I wanted to try something similar. So I want to set waypoints in between my apartment and Safeway such that they overlap so that the robot at any given time could know which waypoint it's closest to and then navigate to it and then go on to the next one. So that's the plan. We're looking for help. And if we can successfully get to Safeway and back doing our shopping, we want to try to fund it and come up with a robot that does pretty much what other robots can already do, but it'll have an arm on it. So it'll do things like pick up your socks, go to Safeway for you. Who knows? Just a fun project. So that's pretty much it.
I think I saw a question about how it's run. What was it run on? It was run on VNC on a hotspot with John's iPhone. If that answers that person's question.
How did it navigate? Someone's asking. I'm asking too. Were you using?
It's running on. Excuse me. It's running on VNC. Ask Chris. He knows more about it. But
Yeah, the video feed, we're looking at it over VNC. I don't like VNC very much. It doesn't nearly do as good a job as Remo.tv. So that's why I was interested in turning this into a Remo.tv robot. The first trip out in this video, we were actually driving it through a VNC Wi-Fi connection. So we had a hotspot, I think, on a cell phone, only because the Xfinity Wi-Fi in Belmont was not cooperating, so we couldn't get a Wi-Fi signal all the way between my apartment and the Safeway. So we just used a hotspot on a cell phone, connected to it through my desktop at home through the VNC connection. And it's great because VNC comes pre-built on the Raspberry Pi. You just have to get a client, and now you can do basically remote control of the computer that way. There's a question about how long it will operate. We made it to Safeway and halfway back. It was about 2.5 kilometers total distance. But as I said, we didn't really know how to drive it straight. So we think we could probably easily get 3 or 4 kilometers out of it. Of course, that's just the battery that we have. If we need to go farther, we'll get a bigger battery. I think, John, you know more about the batteries. I think you bought those.
Yeah, it's just a gel cell batteries, a 6-volt. This one, oh no, that one's a 12-volt gel battery, motorcycle battery. It's solid. It's not no lead acid.
And is the
we can
checkout
also get a
person
12-volt that's twice the size of that one. That's like the medium-sized one, I think.
Yeah, and we're going to have the checkout person in cahoots with us to expect the robot and be able to take the credit card, pay for the groceries, and give the credit card back to the robot. All right, I think that's it for the questions for the Safeway robot. If anybody's interested in joining this project, we would love to have help on this. And there's a lot of fun things to do. Right now I'm working on the vision and and what I call the B navigation system. So if you want to play around with some AI and some unique navigation stuff, please let me know. This is happening in Belmont. And there's also I think we have how many robots? 4 total of these prototypes. 2 of them are in Belmont and 2 of them are in Hayward, right, John?
But hopefully, if everything works out right, we want to be able to run our robot from here to Chris's Safeway and back. We'll have Chris be the spotter next time, hopefully.
Yeah, the idea is you can run these robots from anywhere in the world. And I think Remo.tv is like the perfect way to control the robot. You get a really fast, low latency video feed. We're going to need finer control if we need to take over manual control than WASD. So that's why we're calling this semi-autonomous. I'm hoping to be able to just have a live video feed, be able to click on any object from my living room, such as a stop sign or a parked car, and have the robot say, okay, I see that, and I'm going to go towards that object. How does one join the team? Just send me a message, an email. There's a thread on the news group, so just respond to that thread, or F Dow, I'll get in touch with you. All right, thank you very much. John, you're muted, and I think, Camp, did you have some more robots to show off?
Yes, one moment. I should get some music going here. Pick up the camera and point it to the robot. This is the robot dance party. Can you see it? Hang on. I might need to make myself the spotlight. Oh. All right, am I on? Oh, I'm unmuted. Am I on the screen or not?
I can see and hear you.
Okay, good. This is the Barbie bot. It's an entertainment robot.
That's funny.
Again. And everybody remembers Rocky. The high five robot. There he goes. And I've been around the horn with Turtle, the Turtle bot. I got my SSH working again. Let me just demo a quick map. So here's Turtle down here. It's the Raspberry Pi inside of a bot vac. And I've got the teleop keyboard. Hang on one second. So there he's moving. I'm moving the teleop twist keyboard. You can see it's creating a map here. Upset the cat there. We're going to map into the other room. Let's see it. So you can see it's creating the map as it goes along. You create the map, you save the map, and then you're able to navigate within the map. Typically, I have some code called floorbox that I can go from one end of the room to the other and back. I was having trouble with my navigation earlier, so right now I'm just showing the mapping demo. This is from the Intro to ROS, the SV ROS Intro to ROS package. And so here you can see I've created a map from the starting point into the living room here, and then I can save this map and click from one place to another, and the robot will autonomously navigate there. Just got a couple of other pieces real quickly. I'm writing a book. Part of it is just homebrewed robots, and this is Arduino on two 4-inch acrylic circles. I've got the servos here. Incidentally, I found these micro servos with wheel combinations you can get for $6, and I put some little whiskers on it, and this will be a starting robot. It's just a simple bump left, bump right sort of thing, but you know, to get started with the Arduino. I've also found a real interesting chassis from, like I say, I got these micro servos with wheels. You can buy them from Amazon for $5.50 servo and wheel. And I found this from Robot Shop, and it looks like the same micro servos with wheels with the chassis. They were selling it for $12, so I got real excited and got it. But what they've done is they've stripped out the controller, so it's just a DC motor gear with the wheels. I've looked further into it. VTech out of Shenzhen, they sell a dual motor controller that you can use the RC code 1 millisecond, 2 milliseconds to go forward and reverse, and it's about $3. So I'm going to get some of those, and this makes a really good, inexpensive platform. Finally, and many of you have seen this before, this is Rodney Jr. It's an experiment in machine intelligence. It goes forwards and backwards. It said he learns to go forwards and backwards. I've got a Roomba caster wheel here, and basically when you look at a differential drive system, there's 9 possible motion codes. Only 2 have or displacement forward and reverse. So I'll switch the robot on. Initially it's random motions. Then he'll, for a particular response, he'll learn when he's in a particular motion pattern and has a response that's successful, he remembers that. So the next time he's in that motion pattern, he'll try that again. If it continues to be successful, he increments the confidence level. If it's no longer successful, it decrements the confidence level. In the gamma level, when he's in a particular motion, which he has no high confidence responses, he'll try high confidence responses from other motion patterns before reverting back to random patterns. So you see here the robot's going backwards and forwards. It's not the robot's going backwards and forwards, it's that it learned to go backwards and forward. I'll try it one more time. The random motions. When the red light goes on, he's not happy. He's doing random motions and it's not working out. When the green light goes on, he's happy. That is the little encoder wheels flipping. That is, he's going either forward or reverse. So there again, you see he's going forward and reverse. It's not that the robot goes forward and reverse. It's that he learned to go forward and reverse. Thank you very much. That's all.
All right. Is there anybody else that we missed who has a robot or something cool to show?
Would you like to see my the orange robot? If there's time, I have a video already made. I can show part of it, like first couple minutes.
Sure, take it away.
All right, here, let me share. Can you see that?
Yep, we got it.
Orange, get map. Okay, get map.
Well, we're not seeing the video, we're just seeing your directory.
All right, hold on a sec. That's why I'm asking, because it's kind of a here. Okay, screen. Now, all right, you see the video?
See the
There we go. Yeah, that's it.
Orange, get map. Okay, get map. Got file and loaded robot. Orange, rotate right 90. Okay, rotate right 90. Orange, rotate left 90. Okay, rotate left 90. Orange, go to living room. Okay, living room. Moving.
So I had previously mapped the house by driving the robot around and using that Slam Tech technology. And they even have an app, a Robo Studio, and you can see the map that it's making. But it's purely LiDAR based, and it uses the odometry and the encoders as well to integrate to locate the robot, and it does a pretty good job mapping it. Now I'm learning about how that actually works by taking that nanodegree program from Udacity, which is teaching me exactly how
Orange.
you really do that coding.
Okay. voltage. Battery percent equals 100.
Orange, get location.
Okay, get location. Location, x equals 0.047570, y equals dash 3.755553.
Orange, go home.
Okay, go home.
What's also interesting is, in this case, you'll see, I told it to go home, which should mean turn around, but if you could see the map, it plotted a new course through the sliding door, glass sliding door, into no man's land or into unknown area that it hadn't mapped. And it discovers that, well, maybe this isn't the right way to go, but it's the path planning tries to plot best course, and if it fails, it retries. And this is all part of the Slam Tech core. They call it the Slamware. So you don't have to learn how to, you don't have to program all this. You can use it through an API and just say, go to these coordinates of the map. So it's quite user friendly, reasonably anyway. I've started writing code to try to explore a room. I haven't gotten back to it, but I wanted to automate the mapping process. So I wrote some code that would go, for instance, along the long length of a room and map it, and then it's started to work. I haven't, I'm still working on that code, but I want it to then go to the next room and map the next room and recursively, I guess, and map the whole house automatically. Orange, turn off.
Now, are you using the A-star algorithm that came out of the Shaky project?
Actually, again, like this is, yeah, the Slamware, I'm going to stop the share here. The Slamware core code actually uses, I think, a D-star. I think it's D-star. Are you familiar with that one? It's like one of the newer path planning. But again, that code is inside the proprietary system that's on board. It's like it's actually a Linux system. The main board is an STM32, and then on that board is a card, and on that card is running a Linux system. And I hooked up the serial of that, and I could see it booting up. But essentially, yeah, if you go to the Slamware or slamtech.com, they explain some level of detail of how they're doing the path planning, or I mean, just the names of things like I think it's D-star, but it's similar to A-star path planning. But I haven't coded it myself, so I can't claim that. But that's it. Oh, and I added the sonar, and the next, I won't show it, but there's another video that shows it bumping into something. The bumpers are integrated into the system, and it will back up and go around the object. And as well with the sonar, that integrates in along with the LiDAR. And so you send all that information to the Slamware core, and it will try to avoid. So if it gets within a very close to an object, the sonar kicks in. Now, what I'm saying is that for instance, the object is below the LiDAR level, so the LiDAR can't see it. So then the sonar is at a lower level, so it can pick it up and it can avoid that obstacle, but not as well as the LiDAR is the best. Anyway.
Very nice.
Thank you.
Yeah, very nice.
And that's my project I've been working on a lot. And I've got more plans for it, and we'll see in the future with probably my RGB, well, the Xbox Connect depth sensor. You can hook that up to it as well. Thank you, Sergey. All right, thank you.
All right, is there anybody else that has anything cool to show?
We had 15 demos.
Yeah. But only one for the challenges. We did an arm challenge. Nobody did oh, you did a tabletop.
Run what you brung is a challenge, Chris.
That it is. Well, I think we'll just leave this chat open for people to ask questions and talk amongst yourselves for a few moments until camp gets tired. I think it's almost nearing midnight in Florida there, right?
I'm just getting started.
All right. Well, I want to thank everybody to coming to this June HBRC meeting. Look forward to seeing you next July. I don't know who the main speaker is going to be, but we can check that on the main website. We'll have that up there, and then we'll have it announced in the news groups. So thank you, and everybody have a good night, and keep building robots.
Yay! Yay, robots!
Bye-bye.
Hey, Jim? Jim D?
Yes, that's me.
On Facebook?
Yes, I'm on Facebook.
We have a Homebrew Robotics Club group in Facebook.
Yes, yeah, I've joined that, or I follow you guys.
What? Are we friends on Facebook?
I don't. Well, I don't know if I'm friends.
What's your last name, Jim?
What's that?
What's your last name?
Oh, Dinunzio. Dinunzio.
Yeah. I also wanted to point out, and I'm sorry I didn't earlier, that this meeting was recorded and will be available on the HBRC YouTube channel. So if there's anything you missed and you want to catch it again, look for this video on our YouTube channel. Now the chat does not get saved. So if there's anything that you saw in chat that you want, you're going to have to copy and paste it. And I do apologize that Zoom does not allow recording of the chat feed.
There's no telling how it'll turn out because the spotlight wasn't used all the time.
There is a button.
The host should get a transcript of the chat.
We'll see.
We have a late entry. Dan is going to show a new servo design that he's been working on.
Hey, that's 16 demos.
Only 2 hours late, but come on and show us what you got.
Put me up there, man. Put me on the big screen. Hey.
You're on the big screen.
Can anybody, I don't know if anybody can see me. Can anybody see me?
Yes.
You're Karen, right?
Yeah, I'm Karen Dan. There you go. Great. Hey, okay, guys. Hi. I show this every month, and I just wanted to see if anybody wanted to sort of collaborate with Chris with his bot that goes on his cans. And I thought, well, you know, I work with Karen. You can see her in the background. And arms are really important. So I thought, well, why don't we all kind of collaborate and build an arm for Chris's bot that can grab cans and stuff. The mechanics of it is it's mechanical engineering. I'm going to show this again. This is from MJ Bots, and this is the bracket of the demo quasi direct drive. I'm going to say that again a little faster. Quasi direct drive. For those that don't know what that is, it's a low ratio planetary gear drive with a motor internally that kind of looks like one of these guys that you've seen on quadcopters and things. And basically, it produces a lot of torque, but it also back drivable. It's really back drivable. So you can kind of do all kinds of things with it that you can't do with regular cheap RC servos. Like you can hear it. And these are pretty pricey, but I don't think they're too pricey for what you get. And there's a CAN bus on there, and you can, if you go to MJ Bod, 3 or 4 per Pi hat that's on there. And that being said, I'm willing to buy the materials and pay for the arm and stuff for Chris's robot to pick stuff up. But I need other people to get involved too. I have a day job. Everybody has a day job. And we all want to sort of build robots. But if you like what Chris is doing and you want to collaborate, I'm working with Chris a little bit. I have been for years. And, we're trying to put a team together. So if you want to be a member of the team and you think you can contribute. Yes. Yeah.
You're actually working on a wheeled robot?
No, I'm working on the upper half that has arms. Chris works on the wheeled part. I would never work with a wheeled robot. Come on.
Just trying to understand. I just want to make sure you wasn't going backwards here.
No. I am going. Look, hey, we all have. It's a little give and take. I've decided if you guys could put arms and limbs on your wheeled robots, I can use a wheeled base and get started. We could sort of collaborate until the world again divides between wheeled and walking robots. But for now, since you can't go down your normal Radio Shack or your Robot Shack or whatever and buy a robot like we thought we would have by 2020, and we don't yet, well, at that point, I think that we need to sort of stick together. We're a small group and, work
Sounds
together
a little bit like
to achieve the goal. Yeah, so anybody that wants to get and work on the project, contact Chris. Chris is always in touch with me. I figured the people that were still hanging on after the meeting were the diehards that might really love robotics and hang out and have nothing better to do in their rooms during COVID. So that's pretty much it for me, my rants and stuff. So back to anybody else?
I think this is random access.
Yep, we're now in random access. Thanks, Dan.
Is there anybody left?
Few people here. How you doing, Bob?
I'm doing good. How are you? You look great, man.
Thank you.
Yeah. Hey, just got something. I've been experimenting with trying to get my 3D prints look halfway decent, and I've come up with this guy, which is half of the head. I don't know how well you can see it, but he's.
Hey, Bob, you need to turn on your video, buddy.
What's that?
You need to turn on your video.
It's on.
It's on. I can
Yeah.
see.
I can see him fine.
I can't.
Okay.
Oh, maybe I need to start my
video.
You need to turn on your video.
Yeah, but now I'm on the screen. So how do we do that?
Hang on, let me unspotlight you, Dan.
Yeah, I think that's
Thanks.
what you do.
Yeah, that's the
Okay,
host
yeah, somebody needs to be in control. So somebody has to spotlight the guy who's got the mic.
Well, if you don't spotlight, it'll just be whoever's talking.
Right.
It should be, but I'm not seeing Bob.
I think
Yeah.
you're still spotlighted on Dan.
Yeah, I see Dan. I can't hear him.
And he's muted. You're
Yeah.
muted. I think maybe you muted him rather than unspotlighted him.
Yeah, the host muted himself and is unable to unspotlight Dan. Yeah, Camp, you're muted.
Yeah, I'm muted, that's right. But when I go to Bob more, all I get is an option to stop video.
No, I don't think you need to do anything with Bob. You just need to, well, I think you just stopped his video, but if you just unspotlight, you have the spotlight on Dan still.
Yeah, I'm looking at Dan and I go to more and I don't get an opportunity. It doesn't say anything about unspotlighting him.
So my video just went off and it says that the host has killed my video.
I think
Right,
you can restart it now.
the host now controls the video.
Oh.
Your host asked to start
video.
my video. Okay. I started my video there. Is that better?
Can anybody
see it? You're just small because it's still stuck on Dan.
Technology is great when it works.
It's not just stuck on me. When I start my video, it says you cannot start your video because the host has stopped it. So it's not stuck on me.
I'm going to ask for a start video, but I had an opportunity. It allowed me to put the spotlight on you, but when I go back to you now, I can't stop an option on spotlight. Here we go.
Hey, there we go.
Yay!
The host has spotlighted. So anyway, this is half of the robot head over there, which is a big 3D print. And, you know, it comes out pretty good, but I wanted something that looked a little bit nicer. So I started experimenting with different types of things to make it finish. And actually, I found that just good old wood filler, plain old white wood filler, put it on, it dries several hours. It's easy to sand, it fills all the gaps. And then you spray it with a kind of a primer that has a gap filler in it, and put a couple of coats of paint on it, and boy, does it look a lot better.
Yeah, no, that looks pretty good.
Yeah, yeah. So just as an FYI, and you know, this costs about $6, and you know, lasts forever. So yeah, cool stuff.